Hello. Today we're going to build on what we learned last class about global climate as we understand a really cool weather phenomenon called ENSO, which stands for El Nino Southern Oscillation. Now, this picture in your book gives you an overview of what happens, and it all starts with the pressure over the eastern and western Pacific Ocean flip-flopping, which causes the trade winds to weaken or die off. And this results in a variety of different weather pattern consequences. This short video will give you some visuals.
A natural force of nature unlike any other, El Nino is capable of unleashing a fury of climate changes and natural disasters that span from Alaska all the way to South America and beyond. What causes El Nino, and how are we affected by it? El Nino is not a storm, but rather a weather phenomenon in the Pacific Ocean. During an El Nino, the surface water temperature warms up, leading to complex weather patterns. South American fishermen in the 19th century, describing warmer waters during Christmas time, coined the name El Nino, Spanish for the Blessed Child. Nowadays, when sea surface temperatures in the equatorial Pacific Ocean rise 0.5 degrees Celsius over their historic average for 3 consecutive months, and once atmospheric conditions and rainfall patterns shift accordingly, scientists officially declare an El Nino. An El Nino event takes place about every 2 to 7 years. Normal east to west trade winds over the Pacific weaken, and warm water that normally travels westward is now moving toward the east. Moisture then rises into the air, and the effects of El Nino are felt throughout the Americas. In the ocean, warm water pushes colder water downward, blocking the important upwelling of nutrient-rich waters from the bottom. This causes some marine life to migrate to colder waters. Animals that normally feed on the sea life suffer, and fisheries throughout Central and South America suffer too. But El Nino's most noticeable repercussions are felt on land. In the western United States and Central and South America, the warm air and moisture lead to increased storms, rainfall, floods, loss of life and property, and the increase of some vector-borne diseases like malaria, even in places where they don't normally occur. In Southeast Asia and Australia, the opposite takes place. These areas suffer from drought, wildfires, and colder ocean waters. In 1997 and 98, the world experienced the biggest El Nino in recorded history. Some estimates blame that El Nino for 2,100 deaths and $33 billion in damages. Mongolia saw temperatures reach 108 degrees Fahrenheit. There was record flooding in Peru. And the U.S. saw storms in the Gulf Coast, flash flooding from California to Mississippi, and tornadoes in Florida. Scientists are now better able to predict if and when an El Nino event will take place. This helps communities better prepare for the changes in weather patterns and better adapt to its repercussions.
So, El Nino is when surface currents in the equatorial Pacific Ocean, that means the Pacific Ocean along the equator, reverse direction. It happens every 2 to 7 years, and a big indicator is when warm waters appear off the coasts of North and South America. Normally, those waters are very cold. And it impacts climate in a variety of different places on the planet. It results in cooler and wetter conditions in parts of the United States and unusually dry weather in Southeast Asia and Australia. Now, the reason it's called an oscillation is because we have normal conditions, but then at some points, every 2 to 7 years, we have an El Nino, and that is generally followed by something called a La Nina event. So it's El Nino Southern Oscillation. It has a lot to do with the trade winds, which normally blow from east to west in the northern hemisphere, and then in the opposite direction in the southern hemisphere. This short video will remind you what we learned about the trade winds.
Here we're talking about 30 degrees north, 30 degrees south, those latitudes there, and then we've got the equator. So we've talked about this before, how wind blows from high pressure to low pressure. There's a natural occurring area of high pressure right along 30 degrees north and 30 degrees south. So wind blows from high to low pressure. At the equator, there's a constant area of low pressure. And so you have these winds blowing from high to low, but because the Earth spins on its axis, the Coriolis force forms, or the Coriolis effect, and that causes this apparent force for those winds to slant. In the northern hemisphere, they curve to the right. In the southern hemisphere, they curve to the left, and that's what creates those easterly winds from 30 degrees north to the equator. You have the winds slanting to the west, and we call those the easterlies because the winds blow from east to west. So let's talk about why this is called trade winds. Back in the early centuries, this helped ships navigate across the Atlantic from east to west, and the origin of the word trade is track or route. Here we're talking.
So first let's understand normal conditions. Normally, we have very strong trade winds that are pushing surface water from east to west in the equatorial Pacific Ocean. So what that means is from North and South America across the Pacific Ocean towards Southeast Asia and Australia. This is normal conditions. Now this allows something very important to happen, and it's called upwelling. When the trade winds push this surface water away from North and South America, they create a space essentially for water to rise up from the ocean bottom and bring with it all kinds of wonderful nutrients that are there because of decomposition of dead marine life. Well, those nutrients will be wonderful for photosynthetic aquatic plants and therefore promote a lot of productivity in the entire food web in these areas. And that's why in normal years, the fishing is really great. And a lot of the economy, especially off the coast of South and Central America, is based on fishing. What this means across the other side of the Pacific Ocean is that warm water will build up off the coast of Asia and Australia, and this will cause a lot of rain because the warm water will heat the air above it and it will create monsoons, lots and lots of rain in these areas, and that's why growing rice is a great part of the economy in Asia because it requires a lot of rain. In an El Nino year, these trade winds weaken or completely die off. And that means the warm water reverses directions. It starts moving not towards Southeast Asia and Australia, but away from those areas, back towards Northern and Southern Americas. And this creates a lot of rain in North America, which is not normal. And it creates droughts in Asia and Australia, as you saw in the video, droughts which can even lead to fires. And most importantly, it stops the upwelling, which decreases productivity in the ocean along these coasts, and it reduces the fish populations, especially off the coast of South America. So it's really bad for the fishing economy during an El Nino year. El Nino is almost always followed by La Nina, and that is, you can think of it as an extreme normal. What happens during a La Nina is the trade winds are very, very strong. So they're going in the normal direction, but they're stronger than normal. And that means this cold water that started off the coast of the Americas goes a lot farther along the equator before warming up. And it causes parts of the southwestern United States, like California, Arizona, and Nevada, to get a drought situation. And then in Asia and northern Australia, they experience higher than normal rainfall, which can cause flooding. Okay, if you would please open the document called Enso Exploration and we'll preview that together.